So it says J is perpendicular to R. Let's go ahead and mark that. J is perpendicular to R. And then it says K is perpendicular to R. How do you know that J is parallel to K? It's one way you know. They're both perpendicular to R. Yeah, that's one way. So you can put that down. They're both. That was from the last one. How else? Yeah. Could sort of. You can. We'd have to have one more piece in here, but so the fact that J is perpendicular to R and K is perpendicular to R, there's a theorem from last unit that says since two lines are perpendicular to the same line, they're parallel to each other, it's kind of transitive property. That's what that theorem said. I don't remember the number of it. But any other ideas on it? I marked the little red squares. I marked in specific positions too. Yeah. Corresponding. Yeah, that would work too. As a matter of fact, all of these are right angles and all of these, so you can use any of those converse theorems. What about B here? What kind of angles are the 70 and 110? Remember?
Same side interior.
Yeah, same side interior, so you can use the same side interior angles converse to prove these are parallel. So this would be same side interior angles converse. When you see that these same side interior angles add up to 180, it makes J parallel to K. Here we said if both J and K are perpendicular to the same line, they're parallel to each other. So that's why. We're going to talk about constructing with compass and straight edge, parallel and perpendicular lines. Do you remember how, or could you describe how we do a construction for a perpendicular bisector? Do you remember? Yeah, do you remember?
So you make like the straight line.
Yep.
And then you take one of the angles and make it so it like you like make like this motion.
A half circle, yeah. So from one end of the segment you drew, you do a little half circle. And then what do you do for the other one?
You do the same thing, but flipped.
Yes, on the other side.
The cross section between the two is where the line should be.
Yeah, so you do from each side, and I could show you just so you could see what we're talking about on here real quickly here. Don't write this down yet, but just let me show you what that looked like. So we would do this, and then we'd take this thing. You know, what's one thing that's important about this? Yeah, otherwise it won't cross. But you stretch this thing out, and then you could just swing a half circle from that side, and then go over here and do the same thing from this side. And then the crossing of those two is you could draw through here. I'm not going to take the time to bring my straight edge up here, but if I drew right through here, I'd have a perpendicular. That wasn't bad. But you have a perpendicular bisector. So we're going to look at two other perpendiculars. Like we're going to create perpendiculars to the line segment. They won't necessarily be bisectors, but from a point not on the line and from a point on the line. So it's like if you're creating two streets where you have, you know, a kind of a T, and you want that T to hit right at a certain point, you could guarantee that. And then we're also going to use the idea of corresponding angles to construct parallel lines, a whole series of parallel lines. That's how you're going to start your designing a city project, is by making a whole bunch of parallel streets. So you're going to be not anything like where we live, but like if you're in the city and you want to know these parallel streets that you could easily create in flat, flat land, Doesn't quite work that way where we live. It's kind of funny, but we're going to do that anyway. So let me reset this. And we're going to go ahead and, like, as low down as you can on it. I think you have some space. You have some instructions, right? Does yours start with constructed keeper? Yeah. You have some instructions. You have some space below it right here. Go down to the bottom of that space, so towards the bottom of the page, and then just draw a line segment. So towards the bottom of the page, draw a line segment. As close down to the bottom as you can. You're going to come up from there, yeah. Everything's going to be built up from there, so as close down to the bottom of that page as you can. I learned from yesterday. So you guys are benefiting from the mistakes I made yesterday. So there's, and then we're going to. Okay. And then we're going to take our ruler, and then you're going to just draw another. This is kind of like having a street coming through at whatever angle you want. So it doesn't have to be to match mine exactly, but you're going to draw some street coming through here like this. And then pull that ruler away. That's how we're going to start. And we're going to bring the compass into the mix. So you got that going on? Okay. So what this is, we're going to create several parallel lines using the idea of congruent corresponding angles. Okay, this is one way to do it. You might probably think of other ways to do it. But we're going to build a bunch of parallel streets here that have the same angle as these two intersecting lines right here. So take your compass, place your compass point, which is different than my compass, but your compass point, place it at the vertex there. So place your compass point at the vertex. So the little clear circle, place it at the vertex, and then you have to take your slider and slide it a little closer. And you're going to swing an arc through here, and I'll give you time to do that. Swing an arc through there that intersects both rays of the angle. Swing an arc through there that intersects both rays of the angle. You have to adjust your pencil so they'll show up. I'll give you time to do that. So place your compass point or your little clear circular piece there on that vertex. Take your finger on it. Find a spot to, it's kind of not too close, but not too far out. Swing an arc there. Yeah. But it's not. Okay. Do you want a different one? Have a different one. This one. Yeah. Well, this one, though, this one, oh, is it not locked? Oh, this one locks. Okay. Grayson, we turned in 3.5 homework too, if you have that. Do you guys get your pencils to work and everything there? Still working on it? It won't go through. Or does it? Let's see here. Move it out just a little bit more, maybe. I'll try it again. Take a step on the page. Yeah, not great for this. Yeah. If you need to, you can borrow one of mine. I have 4 up there. They seem to be sharpened. If you sharpen those guys really well, they look pretty. You're right. Those are a little tricky. That's why I'm giving you extra time to do. Did everybody get that arc on there? Okay. You got your arc? Okay. So what we're going to do, this is one way to do it, and there's different ways to create these parallel lines. This is one way to do it. I'm going to go up here, keeping that same arc length, okay, just because it's kind of a pain to set it and get it all set up. Keeping the same arc length. I'm going to move my compass point up so that it's right here on that diagonal street, if you will. Do you see where I put my compass point? Just right where it intersects the ray of that diagonal street. Then I'm going to swing another arc, and I'm just visually going to swing an arc so that it looks like it comes down far enough so that, here's where we're headed with this. I'm going to have a street drawn in right through here. It's going to go through that arc. And so I want to draw my arc down enough so that when I measure the gap in the angle here, it's going to be able to crisscross with this arc here. So make sure that arc comes down enough. It doesn't need to touch the first arc, but it needs to come down enough so that visually you could see a parallel line going through there, and we're going to get exactly where that parallel line should be in just a minute. So we're going to do one of those, and then I'm going to do another one up here. I have room for one more. Yeah, right up there, I just barely, if you need to, you could extend out your line a little bit here. I just barely had enough. But we're going to actually construct 3 parallel lines here, and this is what you're going to do on your little project with the street. So take your compass point, place your compass point right here. Okay. Compass point goes there, and then I swung an arc, and then I moved my compass point up to where this arc intersected, put my compass point there, and swung another arc. That's it. That's what I've done so far. As I've swung 3 arcs, all the same distance, the same gap, if you will, along this diagonal line. Okay? You got it? So let's see here. So right here, let's go ahead and type it out. We have 3 little arcs there. And I'll show you how we're going to measure the gap. Do you remember the copy and angle construction? So we go right here. So we want the same distance again. So we want to slide and block out. And then move up here. Depends on the just a little ways down. All right, so now here's how we're going to measure the gap. You guys ready? This is the key to this, because this is what's going to give us, man, some corresponding congruent angles. Is we've got to have this gap right here from here to here. I'm going to show you on here. Has to be copied over and over again. See, it's not. I don't have it. It's not the same as the arc I took. It's possible that the same arc you used to swing your first arc, and then your second, your third arc, it could be the same as the gap. In my case, it's not. See how I have to bring my compass in a little closer? So on yours, you'll have to loosen it, and then get as best you can. I know it's hard with those, but get the crossing of the arc with this bottom segment in the little crosshairs of one of those circular holes. So what I'm going to do, I'll do this on mine here. I'm going to try and adjust it here. Pretty close. I think that might be the closest I can get. And I'm just measuring this gap here. Okay, that's okay. I don't have to do. But I'm measuring that gap with my compass. And then I'm going to copy that gap or copy that angle 2 more times. And by copying that angle, I'm creating congruent corresponding angles above each little parallel street. Okay. So I'll show you here in a minute. But measure that gap. So everybody measure your gap. Just this one right here. Go ahead and do this right now. I need everybody to measure that gap, and then I'll show you what to do with that gap to create our parallel lines. We're almost done with the construction. You got the gap measured? What's bigger than this gap right here? Oh, no, not from there. From here. It's got to be between here and here. So I'm measuring the gap here where my arc crosses through the 2 rays of my angle. And then lock it out on that gap. You need that gap to be copied over and over again. Okay? This is how you'll start with your little project you're going to do. So this is pretty important. As you're working on your project, I can come around and talk to you about project. You aren't quite understanding this. But this is how you're going to create a bunch of parallel streets. I think it asks for 3 of them. So everybody got that gap measured? Yeah, because you got to watch what I'm going to do next. So I'm going to move this over here and place, look where I'm placing my compass point. See that? Placing my compass point right there, and I'm going to swing an arc there. And then place my compass point up here, and swing an arc here. And I could keep working my way up all through the page, right? And what I'm doing is creating a whole bunch of parallel lines. Here's where my parallel lines are. I've got a parallel line right between those 2 dots, between these 2 dots, and of course I could keep going forever and ever. I cheat a little bit here because I've got the special protractor ruler. Right? So I can set it 0 degrees. So I don't actually need to construct it, but that's what we're doing, is we are constructing parallel lines. When I say constructing, we are using geometric definitions to guarantee that these lines or these streets are parallel. And the geometric definitions or theorems I'm using are corresponding angles converse. So those are my those are my 3 parallel streets. So now you connect here with here, and then here with here. You just created 3 parallel streets. It's like there's the railroad tracks coming through there, or something like that, and you've just created some parallel streets that crisscross the railroad track. You might do a gap at all. Yeah, it's this original gap right here was only that distance away, so we wanted to measure our next arcs from here. From here, it should come in here. Like this gap and this gap is coming out. Yeah. What you could do is measure the same gap, but like you would have had to pick a place and put a point here. And then that gap would have to be the same as this one right here. Maybe save it. So that would be a way to do it without having to use the same gap over and over again. You have to point somewhere on there. So these gaps are the same as this one. You cannot quite eyeball them, but you would have had to pick this point ahead of time, and then when you have this distance, measure it there and there, then you would have had it. Yeah. So hey guys, if you want one thing here, if you didn't want these streets to be all the same distance but still parallel, you could have picked a point anywhere on this angled ray here, and then measured this same gap that we have down here. So for those watching at home, it'd be this gap right here where my little green dots are. That gap just needs to be copied again from wherever your point is on here. It's just easier to create like you already have that gap from your first arc, right? It's just easier to create a couple more gaps or 3 more gaps that are exactly the same. And then all your streets are not only parallel, but they're the same distance apart then. It makes it, yeah, easier. Okay, so assuming each of these are the same, then what we should be measuring here is this gap right here. From here. So you can't really measure, it's too close. So was anybody's arc too not far enough out and it was too close? Like if you go, I'm looking at Eva's here, she's got it in as far as it'll go, and that's not enough for the gap, so it won't work on yours. So you'd have to have a different arc coming out. But if you could measure it and measure from here to here, you have a little arc here, you'll just eyeball it. You connect these two to make your parallel line. You just can't measure the gap accurately because it's too tight. It's so close, yeah. You just can't do it during the question of one. And you measure this gap again and swing it out up here. So when you do this little project, just keep that in mind. Anybody else need help? So you're measuring this gap right here. Right, let me just show you guys how you would make a street that tees here. So here it is, constructing. So go down to the very bottom, that space on there. You see how in example 3 there's space. Go to the bottom of the space. Well, let's see. Oh man, well maybe not the bottom. maybe in the middle of that one. You already draw it at the bottom. Just draw another line maybe on this, right in the middle of that space. Because, I'll show you why. Maybe in the middle of the space, a line. And then, so just draw a line segment and place a dot on the line segment. And it can be anywhere on there. I prefer you not put it in the middle. If you put it in the middle, you're doing the same thing we did with the perpendicular bisector. And this is different than that, slightly different. But same idea, the same thing that Theo is kind of describing, is you're going to end up creating an arc from each end of it. But here's the deal. Here's the deal. And I call this one, this is like the TIE fighter from Star Wars, or like the one that the bad guys have. Dark side. You'll see here in a minute. We've got to create basically two endpoints of a segment that are equidistant from this point. And those are the wings of the TIE fighter. So the way it works is like this. You take this compass over here, you place the compass point right there on wherever your dot is, and your dot does not need to be in the middle of the segment. I'd actually prefer it not be in the middle of the segment. Yeah, that's good. And then you're going to create a little equidistant deal on each side. So you're going to swing an arc here. Now, the only thing is maybe, I don't know if you can make your compass go close enough to create a little, there's the TIE fighter there with the, that's where Darth Vader would sit, you know, in the wing. See it? No. Okay. So what you're doing is creating your own little line segment about that point that you stuck on the line. And now what we're going to do is create a perpendicular that goes runs right through that point that you put on the line. Okay, so it's kind of bringing the perpendicular right to that point. So does everybody have a little TIE fighter wings there? Were you able to get it close enough to swing an arc on each side of it? Let's try it. It's going to go down here across the line. Let me do another one on the other side. You might have to take your paper out of the binder here. It's just because it's hard to work with out there and define it. All right, and then what we're going to do is the same thing Theo described earlier. We're going to maybe not do a full half circle. You could, but take your compass, put your compass point on each end, and then stretch this thing out a little bit more. So what we're going to do, get this guy out of the way, is swing an arc down here, and then a swing an arc up here. And you could just do a half circle if that's easier for you. But guys, this is a different length than what I used here. Okay, I stretched it out a little bit more. Or you could use the outer circle of your compass if you want, and you don't have to change it again. And then I just go to the other side and do the same thing. So it is really the same construction as the perpendicular bisector once you get the little TIE fighter wings. So first step is you get the TIE fighter wings. Did you guys get the wings here? So we'll get the wings by just sticking our compass point right there in the center. And then we swing an arc here on this side, and then on the other side over here. So swing an arc here and swing an arc here. Same distance. I messed up the side there. So we swing an arc on each side, and then I stretched out the compass to get these two arcs out here, above and below. So I stretched the compass out, or like I said, on yours you can use the outer circle. If you use the inner circle to get the TIE fighter wings, keep it locked and just use the outer circle to swing an arc above and below from each side of where the TIE fighter wings intersect the segment. And then if you connect those, here's my cheater, it's 90 degrees, but anyways, Yeah, I have a protractor on here, so I'm not really cheating, sorry. But I can see that I've got it 90 degrees. So I'm going to connect these two. And I've created a street that hits at a 90 right at that point, that arbitrary point, somewhat arbitrary point I put on the segment. So that's it. That's the TIE Fighter one for bringing in a street perpendicular to a point. And you can make it T right here if you wanted to. What's up? Okay, I'll have to look at it. Let me do the one more here and then I'll look at it. All right, this other one is from a point to a line. So let me think about this one. So this is what I call the smiley face one. This is the smiley face. You can make the segment maybe once again kind of in the middle. You don't have to go all the way to the bottom. So draw your line segment. I'm going to bring my compass back down here. We're going to put a point somewhere just off this line. Maybe don't put it too far away. Oh, here, I have a point already. Look at that. It just showed up. So there's a point. I actually accidentally touched the screen. There's my point right there. There's my point not on the line. And I'm going to put my compass point on that point. And then what I'm going to do from that point right there, this is the smiley face part. Mess up that thing. Is I'm going to swing an arc that intersects. There's the smile.
Oh, I see.
So I'm going to swing an arc from that point, not on the line. I'm swinging an arc from the point not on the line that intersects the segment twice. If you didn't stretch it out long enough so it intersects twice, you got a problem. If it just barely touches it or doesn't even get to it, you need to stretch it out longer. So create your smiley face. If it goes through there and it looks like it just blends in with the line, it probably won't work. You got to see two distinct places where the edges of the smile intersect the line segment. So this is what I call smiley face. And all that we're doing, once again, is creating two equidistant points from where, if this point were on the line segment, you know, it's creating two equidistant points. And then from these two places where the smiley face intersects the segment, what do you think you're going to do? Swing some arcs that intersect, right? And you could swing them above or below. I don't know how much room you have on there, but above and below here. So let me get this guy out of the way, maybe. And you could probably keep the same arc. I think will probably work unless you're going right off the page. But swing an arc down here, go to the other side. Swing an arc right here. You should be able to, or you can do it above if you don't have the room, as long as it doesn't go through that same point. But from these intersections of the smiley face, swing a couple arcs, and then connect that with your point. You could swing them above if you wanted to. Doesn't really matter. Somehow you got to connect them with this point. Right through there. And you've got it. Let me pass this out so you can read this thing here. And I'll come around and help you with either of those constructions. And then we'll get started on this together. You're going to work on this, at least the construction part in class, and the rest of it you can do at home, the labeling of the pieces. No, you can get help. This isn't really this is more of an activity or project. You can get help from me or from somebody else, but you're each doing your own. You're creating your own city here. We'll get started together. Let me stop this. So everybody got this down. I'm going to stop the instructions on the constructions.